All right, here we go.
So I feel like you might just be making this up.
Not. Just you wait. Okay, Unit 5. Polynomials.
There seem to be some holes in your story.
Okay, okay, so polynomials, we have spent a very long time doing x squared. Now we're going to do x cubed and x to the 4th and x to the 5th and 6th and 7, whatever, anything more than 2. Usually we stick between 3 and 5, just because. All right, so polynomials is everything we've been doing, but the exponent goes up. We're going to graph. We're going to factor. We're going to solve. Those are the 3 things that we're going to do this unit. There's no word problems this unit. Right? Okay, but that's what we're going to learn to do. So we have to introduce some more vocabulary. So 5.1 is going to be graphing, okay, slash writing equations, graphing, let's just say graphing, writing equations of polynomials. That's EQNS, equations. Okay, in order to graph polynomials, we have 3 things you have to know, okay? One of them is the leading term, and that's what we're going to do. The other one is the end behavior. Where do my arrows go? So when you graphed a parabola, it was either up or down, okay? Where did the arrows go? Now we have 2 more choices, up, down, or opposite. And then we have, what do my x-intercepts look like? Okay, so here we go. A, the first thing we're going to do is we're going to look at standard form. Okay, so I've written it down for you here. Notice it kind of looks like the quadratic formula format, ax squared plus bx plus c, except that notice that this is just an n. That's because the degree is more than 2. Or we will include ones that have degrees of more than 2. All right? So how do you know you have a polynomial? You have positive or 0 integer exponents. So these exponents are positive or 0. Notice that last term has no x. That's okay. That's the 0 exponent. Okay, positive or 0 integer exponents. Now, the thing we really need to know, leading term. Okay, the leading term has the highest exponent. Leading term has the highest exponent. So if I am doing this in order, the leading term is ax to the n. Quadratic goes in decreasing order. X squared plus x plus number. This goes in order. X cubed plus x squared plus x plus number. X to the 4th plus x cubed plus x squared plus x plus, it always goes in decreasing order. So it's the one with the highest exponent, okay? So that's your leading term. The degree is n, corresponds to the leading term. And then what goes along with this is the leading coefficient, which is A. All right, so right here. That's the leading term. It's the one with the highest exponent. So in this particular case, the degree is n, and the leading coefficient is a. Very similar to what we have been doing, but now you're going to have more pieces to look at. Because the leading term is the most important piece of what we need to know for graphing, okay, that's what I'm going to do. But notice I have factored form. I still need to know what that leading term is from factored form. FOIL quotes to find leading term. Okay, and I put quotes because in actuality, I don't need to outer, inner, last. I only need the first term, right? I only need the part with the highest power. That's it. Because all I'm looking for is the leading term. That is the first. That's the part with the highest exponent. So I'm going to highlight the things that are important. Obviously, the number. That's part of it. X, right? I'm highlighting the first, but when I do the first, I'm highlighting the x's because that's what I want to multiply. Oh, see those extra exponents? Those are going to change something. Okay, so I'm going to show you what that changes. Squared means write it twice. That's what it means. It means write it twice. Okay, cubed means write it 3 times. Now that gets a little bit tedious to write. Okay, so what I'm going to do is I'm just going to highlight that exponent and know that I have to do something with it. Okay, so we've got this part, and I've got this part. Okay, so my leading term, I'm only going to take the first, and I'm going to multiply them. Okay. All right, that's all I'm going to take out. A times x. Now, I am going to say x squared because I don't really want to write this out every time. The pink is x squared because I had 2 of them multiplied. And the green is x cubed, right? Yellow, pink, green. That's your leading term. A, x, add the exponents. Add the exponents when you multiply. So the degree is 6, and the leading coefficient is a. Okay. B. N, behavior. I'm just going to draw a little line. There we go. Just tie it up. Okay. End behavior. End behavior is when you use the leading term, which I just told you how to find. Okay? When you use the leading term, ax to the n, right? First, you do leading term. Then, you do end behavior. And then last, you put it all together. Okay, so it's when we use the leading term to determine which quadrants the left and right arrows will go in. Okay, the end, left and right arrows will be in. Okay. Even. You guys ready? Parabola. Goes like this. 2 is an even number, right? Even degree. If the leading coefficient, okay, if the leading coefficient is positive and it's an even degree, it looks like this. Parabola that's opening up. That works for every even degree. 4, 6, 8, 10, all of them. Okay? So, what we're going to do, that's what my arrows will look like. At the left arrow and the right arrow. Now, I'm not going to draw a parabola because when you up the degree, the turning points actually increase. So, just going to do a little squiggle. Okay? If the degree is even and the leading coefficient is positive, it opens up. Okay? So I'm looking at the arrows. Right? That's what I'm looking at. Just the arrows. All right, so let's fill out this end behavior statement. As x goes to negative infinity, okay, that's the left side. The negative infinity is to the left on the graph. Where is y headed? Up. It's positive infinity. This is actually the end behavior statement. It's figuring out like where the arrows are. That's what I'm writing down. Okay, so as x goes to the right, whoop, up. That's positive. Okay, so we're going to stick with even degree. What if our leading coefficient is negative? It opens down. Just like our parabola that opens down. Okay, so I'm going to draw a down with a couple extra turning points because I don't really know what that part is doing. Okay, so now we have the left side, right? The left side and the right side. X negative infinity is the left side and down. X to the right side on this picture is down. So this end behavior, I am looking at the arrows. That's what I'm doing. It's not the middle of the graph. It's the end of the graph. Okay, here we go. Odd degree, which is actually easier than even. Okay, smallest positive odd number. 1. Okay, what does y equals 1x look like? Straight line, like this, or I have to do it backwards. Okay. Okay, so where are my arrows? Top right, bottom left. It looks like a straight line with a positive slope. If we have an odd degree and a positive, that looks like a line with a positive slope. Okay, so that means my arrow, looks like a positive slope between those arrows because it's a line. It's a first degree because that's my smallest odd number. okay? And it's positive, so it has to look like a positive slope between the two arrows. Now, instead of drawing a straight line, there might be some turning points or something, right? Because the higher the degree, the curvier the graph gets. All right. Odd degree with a negative slope. If I do a negative leading coefficient, it looks like a negative slope between the arrows. Okay, so that is this. Negative slope between the arrows. With some, I don't know, turning points. All right, now, end behavior is the ends of the graph. I'm just looking at where these arrows are. That's what end behavior is. Where are my arrows? Okay, so negative infinity is the left side. So that's down. Positive is up. Negative is up. Positive is down. Whew. Okay, you're almost there. All right. Multiplicities. All right, last vocab. Then we take a break and practice a little. Multiplicities is how many times a factor, and I'm going to write in parentheses x-intercept, because factors and x-intercepts go together when we were graphing in intercept form. Okay? How many times a factor is repeated. Now, because we're like matching up the graph, what we're going to do is we're going to figure out what they look like algebraically to be repeated once, and what they look like graphically to be repeated once, twice, or 3 times. All right, so over here, we're going to write x minus 2 to the first. Okay, you don't really need the first exponent. I'm just showing you. All right, so my x-intercept is 2, 0, because that's what matches the factor. So over here, I'm just going to put, a dot on the x-intercept. This does not need to be to scale, don't worry. Okay, a first power is a line, a straight line. It's a straight line. Graphically, that's what it looks like. At the x-intercept, it looks like a straight line. Right here. At the x-intercept, it looks like a straight line. Right there. Straight line. You're like, okay, seems okay. All right. Double. Y equals x minus 2 squared. the x-intercept is still 2, 0. Do you know what that looks like on the graph? It looks like a parabola. Okay, it looks like a parabola. So it looks like this. Okay, so keep in mind, we are looking at the x-intercepts to see what it looks like graphically. Okay. All right. It looks like a bounce, right? It looks like it touches the x-intercept and bounces right back off of it. All right. We know that word is called tangent. When it's an even or a double, it's a point of tangency. That's what it means when it touches and bounces right back off. It's tangent to the x-axis. Now, over here it says double or even. The exponent, any even exponent looks like this. Any even exponent looks like this. Right? Double or even. The differences between the 2, the 4, and the 6 are almost negligible. Right? If you are looking at a picture, there's almost no way for you to tell which one is which. Okay? There is a way to compare between them, but when you're given one picture, you cannot determine it. Okay? You can only compare between different pictures. Triple. All right, now we're getting to something we haven't seen yet, right? Because we've done lines, we've done squares. Now we're going to the triple. That's a 3, repeated 3 times, okay? The x-intercept is still 2, 0. Still there, okay? I'm going to add a new word for you. Point of inflection. All right. A point of inflection actually means changing concavity. So it's going to change from concave down to concave up, or concave up to concave down. So the easiest way to draw this is to draw 2 halves of a parabola from the center, okay? Put your pencil on the center. And then to the left, draw a concave down parabola, but only half of it. I've seen what your pictures look like. You got to practice drawing the right shape, okay? Now, put your pencil back on the x-intercept. Okay, to the right, draw a concave up parabola. That is what a point of inflection looks like. It is changing the concavity. So it has to go from curved down to curved up. Now it kind of looks like it flattens. It kind of looks like it flattens right through that x-intercept. And it does. Right? And then it goes back up. Okay. All right, so what we're going to do next is we're going to look at actually creating the graph, okay? So let's see if I can, there we go. So what I did is I put one factor up here, and I'm going to add the other factors, all right? So pause where you're at, okay? And we're going to look here, x minus 3. Okay, that is a parabola, which you know, okay? So right here, you have 2 x-intercepts. One x-intercept at 1, 0. You have another one at 3, 0. Okay, this is a 1x squared if I were to FOIL this, okay? Now this is a x squared minus 4x plus 3. Okay, so it's the same thing. So my leading term is 1x squared. That's up for my arrows. Up. Now we already knew that was concave up because we learned it. All right? Now, what if I make this a square? What if I make this one a square? What happened? Instead of this x-intercept right here going straight through, it became a point of tangency and it bounced off of that x-intercept. Now, what if I were to FOIL this? Okay, I'm not going to actually multiply that out because it's pretty tedious. I'm just going to put x cubed. Notice that if I take the first terms, x times x squared, I get 1x cubed. That's down, up. It's a positive slope. Okay, notice that the purple and the red have the same, like, general arrows. Question or stretch? Oh, yes, awesome, like it. Okay, now look at the x-intercepts. 1 and 3 with a bounce. 1 goes straight through. And when I say straight through, it looks like it goes straight through. Okay, and when I say bounce, it bounces at the x-intercept. The point of tangency is there. So now, let's just sneak a negative in. Okay, negative. All right, so the leading term is negative x cubed. All right, notice it doesn't matter at the x-intercepts whether it's positive sloped or negative sloped. It just matters that it goes straight through. Okay? And then this is bouncing. It just happens to be bouncing on the bottom side, right? On the bottom half. All right. So what we're going to do is we're going to graph some of them. Okay? I'm going to add one more piece here. What would a cube? Okay, so parentheses x plus 1, parentheses power cubed. Whoa. Okay, now I'm going to change my axes here just a little bit so that we have a better picture. And you'll notice that on the grid that I gave you, 20. Right, so if you want to, okay, there's a good picture. I was trying to see everything. Okay, notice. I'm going to go left to right. So at -1, it's a point of inflection because it's cubed. See that? Concave down, switch, concave up. Then the graph has to turn around. At 1, it goes straight through. At 3, it will bounce. Now notice that I'm coming from the bottom side, so I got to turn the graph around and bounce at the x-intercept. Notice that if I put this together, negative x times x squared, hold on, times x cubed. Okay, look at those arrows. They both are down, down. That's because this is x to the 6th, negative x power 6. It has the same end behavior as the purple graph. It just doesn't have all those extra turns. I'm just trying to find the end behavior from the leading term. All right, that's what we're going to do. Okay, flip your page. All right, you should have some blank graphs. Notice that I didn't label the y-axis because the graphs get really big really fast, and I'm really just interested in the x-axis. Okay, so I guess A, B, C, D. Sure. Go for it. Okay. Actually graphing. Putting it all together.
That's not stealing. That's taking. That's being given. Very nice. But do you plan on giving them back?
Yes.
Okay, so it's borrowing.
Okay. All right. Okay, so that's what we're going to graph. Just put a little, oh, that's upside down. All right. There you go. Okay, so we need 3 things. We need to know the leading term so that we can figure out what the degree and the leading coefficient are. All right? Okay. So we get 1x squared times x is 1x cubed. Now, what I do next to that is I put my arrows. This is my exercise today, guys. Okay. Cube. Opposite. It's cubed. Odd exponents are opposites. And so, I just make a note to myself. If my leading term is 1x cubed, it's going to tell me this end behavior. Okay? So I can already tell it's a coefficient of 1 and the degree is 3. That is the whole reason you need the leading term, is to figure out the end behavior. Okay? So now I need to do the multiplicity. So what are my x-intercepts? Okay, so -2, 0, double or tangent, right? Because of the squared, this is a tangent. So I'm going to say tangent. That describes the multiplicity. Okay, and then I'm going to say 3, 0, straight or linear. I don't know which, right? You can start abbreviating T, S, POI, point of inflection. Okay, and then one last piece here. What's the y-intercept? Okay, that means plug in 0, guys. 0 plus 2 squared. No, I didn't teach you that, but that is something you should be able to do without instruction. You just plug in 0. Okay, so -12. So we get the point 0, -12. All right, let's put it on a graph. Okay, so I'm going to expand? No, all right, we got it. So 3 and -2. Arrows. Now, when you put your arrows, just go out a little bit and just put your arrow. It doesn't have to be in the corners. It just has to be in the bottom left. Okay? And your arrow has to be in the top right. So all I do is I just go out 1 or 2 units from the last x-intercept and I put my arrows on it. I'll move this for you. Okay? Now let's put the y-intercept on. Okay, I know it's not to scale. That's why I didn't label the y-axis, because these polynomials get really tall really fast. All right, it's called connect the dots. Literally, connect the dots. So I'm going to put a pencil here just for a little. Okay, so this first one has to be tangent. Just a little, right? Tangent. Now, when I say tangent, it could be tangent on the top half or the bottom half. But based on where these things are to the left and the right of it, I'm going to guess it's supposed to be on the bottom half. because I gotta play connect the dots. Okay, right, those are your choices, but you can't do that. You can only touch the x-axis where you solved for the x-intercepts. Okay, so it could be the top or the bottom, but I'm going to go with the bottom. Okay, now this next one has to be straight. Okay, it has to be straight. Now, I think it's supposed to be the bottom, and it's supposed to go like this because it's supposed to go towards this arrow. And now I'm going to play connect the dots. Okay. Oh, that makes sense. Great. Does it have to be perfect? No. The only points I'm expecting you to go through are the points that we put on there. That's it. Could you use Desmos to check? Certainly. But you should be able to do this without. Okay. Y equals example number 2. Okay, here we go. Same thing. Okay, what's your little... Oh. I'm going to try to do 3 examples, and then we'll switch over to doing your work.
That really did not make me out of noise. I was hoping for. I'm a pro of not mean. Thank you. I really appreciate it.
Okay. All right, you can do it.
We all have one person who just happens to know.
Okay, see if you can find the leading term. Right? Because it's in factored form, you have to, of the FOIL, which is just the first term. Because that's the one that gives you the end behavior. Right? Every time I do my leading term, I write down my end behavior right next to it as like a reminder. Okay. Now, when I write down my x-intercepts, I prefer to go left to right. So even though these things, I look at it, I'm like, okay, so -3, 0 is actually the most left. I like to go in order because I promise you, your brain like mixes things up if you don't. Okay? So -3, 0, and 1, 0. Okay, so this one is straight. This one is straight. I don't feel like writing the whole thing, so I'm just going to write ST for straight through. Okay, you want to make a little note to yourself? It's supposed to be straight. Okay, 1, 0 is a point of inflection, which means it's that curvy thing. Okay. And the y-intercept. That's where you have to plug in the 0. Ooh, 6. Okay, so we get 0, 6. All right, so I've got 3 points and 2 arrows. Put it together. 3 points and 2 arrows. Okay, so in order to do your arrows, you go to the last x-intercept on the left, and you just bloop, come out like 1 unit, put the arrow there. I know the arrow looks like it goes straight down. That's because our graph is really small. It's just barely angled, okay? Just barely angled. That doesn't look right. Okay, that's better. All right, then I go to the other one, and it has to be down. Notice that my arrows come from here. And now you play connect the dots. Okay. So 3 has to go straight. Right? It could be either of those. And 1 has to be that curvy thing. Right? It could be either of them. So when you connect the dots, you see which one of those fits better. So straight. Oh, that looks good. Okay. Oh, look, I'm coming from the top, so it's going to come in from the left, and it's going to leave on the right. When you draw that shape at the x-intercept first, it really does help. Okay. Okay. Last example today. Gonna do one of each, right? A straight, a square, and a cube. Okay. Y equals. All right, here we go. Okay, here we go. Leading terms. X-intercepts. Y-intercepts. All right, give it a try. So while you guys are working, I'm going to take your empty papers.
I've used all that.
Yes. Any empty sheets? Yeah, you should. I think the other one's empty.
Or minus 4, 0. You're not special. Oh, wow. Yeah. He's coming! 5. Accessorize.
Thank you.
Have 3x intercepts? I do.
It does.
Okay. That makes me feel better.
Okay, so there's my work. Let's see. 2, 3, 4. 1 and 2. Okay, so I put them on here. And I need my arrows. So up and up. Oh, and I need my y-intercept. So it goes there. 16. Because make sure you squared the -2, which is +4. And you cube the 1, and then you have the times 4. So straight. At -1, it's a point of inflection. So it's that flattening piece. Notice I'm kind of keeping an eye on what I think will work. Okay, and then the last one, notice that it's above. If this is above, then this is above. It has to start from where it came from. Okay, and then it's easier to, if you try connecting the dots before you decide the shape, it's going to look funky. It is. Okay? Fantastic. You should be able to tell that it flattens here. Okay. Last thing I'm going to tell you today is just a little bit of identifying so that you can do your 5.1. So as I'm looking at this graph, you saw some questions that mentioned positive and negative. Okay? Positive is the top half. You know those inequalities we did? Positive is the top half. Notice how this has 3 sections that are positive. Okay, see this? The even exponent, the bounce, it's the same sign on both sides. Okay, and then the negative. The negative is the part that's asking for below the axes. So you have some things that are asking for sign charts. They're asking you to figure out the above and below for each of these pieces. And you do it by graphing it. Okay? So there are some questions that are asking you about the sign chart, which is just saying, is it positive or negative on each side of my x-intercept? All right? So let me pull that open, and I'll give you an example. Okay, so return to teacher account, edit. Aha! Graphing, edit, right now. Okay, here we go. So let's do one.
Where are you going after?
Yes. Because the x-intercepts would be different. If you reflect it this way, then the sign chart would be opposite. Okay, so here we go.
I don't have that many brain cells down.
All right, look at this. Okay, here's how your sign chart works. Notice that I'm not asking for the whole graph. I'm just asking for above and below. So when you get your sign chart question, it's just an extension to creating the graph. So here's what I suggest. First, do it on paper. Paper or whiteboard. And then transfer your answer. So here we get -1. Okay, careful. Here we get 6/2, which is 3. Okay, so I'm going to make a note. Straight. Okay, x equals -4 is a tangent C, and x equals +1 is straight. Okay, right, as if I was going to graph it, but I'm just labeling the x-axis. Now this is x times 2x, right, the leading terms, times x squared times x. Okay, so this gives me 2x to the 5th. All right, there's my end behavior. Okay, now it's called play connect the dots. Tangent C, straight, straight, straight. All right, now let's transfer this. So plot the x-intercepts. 1, 2, 3, 4. Done. Now change the signs. It's going to start negative because it's below. Because you did all of that stuff. Here, it's still below. Above, below, above. That's what a sign chart is asking you. It's just asking you to tell me where the graph is above and below the axes. And I do it by graphing it. That's how you're supposed to do it. Okay? Which, right, you basically graph the whole thing and then you answer the above and below part. That's what the sign chart is. It's above and below the axes. Submit. Yay. All right, guys. So I would go back and start on the 5.1, which is the graphing part. Okay? We will spend a whole nother day doing some more of this. So if you find something you're not sure about, skip it and try the next section.